So the three main points in this section are reflection and transmission, interference, both constructive and destructive, and standing waves. Reflection is when a wave hits a different medium and is reflected back to the source of the wave. If it bounces off a fixed point, the reflection is an equal but opposite wave. If the end is free, then the resulting wave is a mirror image of the original. The image on top is an example of a free end, while the image below has a fixed point. Transmission of a wave occurs when the wave passes through another medium. The wave looks similar to the original wave, but its amplitude may be bigger or smaller, depending on whether the medium is less or more dense. When a wave is changing the medium in which it travels, parts of the wave are both reflected and transmitted. As you can see, the reflected and transmitted waves head in opposite directions. Next is interference, when two waves collide. There are two different types of interference, constructive and destructive. For now, let's assume that crests have positive amplitudes and troughs have negative amplitudes. Constructive interference is when you have two waves that are both crests or troughs, and you add the amplitude when they collide. Destructive interference is when you have one trough and one crest. When they collide, you find the difference between the two amplitudes. Next, we have standing waves. Standing waves are when a chord is vibrating at a certain frequency and the chord looks as if it makes loops. The ends of each loop are called nodes, while the widest part of each loop is the antinode. These frequencies are called resonant frequencies. The chord that looks like one giant loop is called the fundamental frequency. The following frequencies are called overtones or harmonics, with the fundamental frequency being the first harmonic, and so on and so forth.